All right, here we go. Example number 3. So we're given a function x cubed minus 3x plus 1. So I just sketched the function over here. So again, we already know where we have our maximums and minimums. We can kind of see that on the graph. We just want to make sure we understand the algebra, the derivatives that kind of go to justify why you have maximums and minimums. And so when the questions get more complicated, you can follow that process. So again, our derivative, 3x squared minus 3, do a little bit of factoring. Again, we're not looking for where it's dividing by 0. Our critical numbers are only where the slope equals 0 on a polynomial function. I find two critical numbers, -1 and 1. That tells me to divide my domain into 3 regions, left of -1, so negative infinity to -1, between the two critical numbers, -1 to 1, and then to the right of 1, from 1 to infinity. I can either just use 3x squared minus 3, my derivative. I can use my factors. However it is, I want to figure out where are my slopes positive. If my slope is positive, just justify again my functions increasing. If my slope is negative, justify my functions decreasing, all those kinds of things. So again, the way the factors work, pick a number between negative infinity and -1, such as -2, -2 plus 1, -2 minus 1. Or -3 plus 1, -3 minus 1, -4 plus 1, -4 minus 1. It doesn't matter what number you pick in the region. You get a negative factor times a negative factor, which means the slope is positive. And if you picked either of those numbers or any of those numbers and put them right into the function, 3x squared minus 3, it would also give you a positive slope. And then from -1 to 1, pick any number you want between -1 and 1, maybe like 0. 0 plus 1 is a positive number. 0 minus 1 is a negative number. Positive factor, negative factor, multiply to give you a negative factor. And then similarly, pick something between 1 and infinity. Positive factor times positive factor means the slope is positive in that region. So again, just to justify what the first derivative rule is telling us, when you go from a region of positive slopes to a region of negative slopes, you hit a point in between where you have 0 slope. The 0 slope is your critical number of -1. So your table is justifying that you're going from a positive slope to a negative slope, which means you've got a maximum at f of -1. Again, the point comes from the function. It doesn't come from the derivative. The slope at the f prime of -1 would be 0. The slope there is 0. When you go from decreasing to increasing, from negative slope to positive slope, from negative slope to positive slope, from decreasing to increasing, you go through the point of 1. That's where your boundary is. It's not a positive slope, not a negative slope. It's a 0 slope. That then becomes your minimum value. So again, the function f of 1, not f prime of 1, f of 1 equals -1. So your local minimum is -1. And again, we're calling these locals because there is a point that's way higher. We just don't see it up to infinity. And there's a point that's way lower down at negative infinity. But within our regions of increase, decrease, or decrease, increase, we've got maximums and minimums. If we keep rolling then with question number 3b, if you have a quartic function, all we're going to do now is just use some more of our factoring skills. It's still the same process. Find my critical numbers. My critical numbers are 0, 4, and -1. And again, it's only because that's where my slopes equal 0. I have no undefined slopes this time. I want to divide, make a number line if I want. Negative infinity to -1, -1 to 0, 0 to 4, 4 to infinity. All right, those are my 4 domain areas. I can just take the whole function, the whole derivative, and work it out, or I can take all my factors. Here I put 4x. I can just write x as well. The 4 has no bearing on it. If it was a -4, that'd be a different story because your whole function would then have a reflection. But because it's +4, I can leave it out. Again, the idea is put numbers in and determine if your factors are positive, negative factors, and then multiply 3 negatives gives you a negative. The first factor is positive times by 2 negatives, right? Slope column, when you have negative slopes, your function is decreasing. When you have positive slopes, your function is increasing. So you're going decrease to increase, a minimum at -1. Increase to decrease, right? From positive slope to negative slope, you have a maximum at 0, f of 0. And decrease to increase, you have a minimum at f of 4, right? Those are your critical numbers. And again, you do the algebra. You find the points from the function. If you did a quick little sketch on your calculator, you'd have to set your range really low to get down to -129. But you can see your function is decreasing At -1, it has 0 slope, then it's increasing. And then at 0 and -1, the point 0, -1, it's top of the curve, increase to decrease. Then it decreases all the way down to f of 4. And then after x equals 4, it's increasing again. So that's your calculus justifying what you would have graphed if you graphed the function from the get-go. There's example number 3 for you.